And hello again, and this video is going to be on area, so let's have a look at area. Now, whereas perimeter we added the distance around the shape, that's the sort of the border, the perimeter. What we're talking about area is the amount of space inside of a two-dimensional shape, okay, this space inside. And if you were to paint this shape, how much paint would be required to fill all that in? So it's the amount of space. That space is what we call the area inside that shape. And this can be a little bit more difficult to figure out for shapes that you don't know, but for shapes that we do know, it goes a bit like this. So for your square, nice and easy, you've got length and length. The area of a square, well, the area of any rectangle, I'll do rectangle first, it just makes a bit more sense. And you've got length and width. The area of this guy is length times width, and I'll explain this in class. Length times width. And so for a square it's the same, it's length times width, but it just happens to be the same, so it's L times L, which is just L squared, okay, the length squared, which is nice and easy, and it makes sense, it's squared because it's a square, okay. Good, so we've got those, we've got our triangles, so any of these triangles all have the same, so I'll just draw three different sort of types of triangles that you might come across, and these all have similar properties. It's good to understand how so if that's your height and that's your base, that there is your height, what sort of height there, I'll just draw it in harder, that's your height and that's your base there, and this is your base there, and your height is that there, height there. Okay, so make sure you know. So if you've got that, those types of triangles, you get the area is equal to half times base times height. Okay, so make sure you are doing those. Not very well explained them, but there you go. You've also got parallelograms. So parallelograms are like this, when you've got all your opposite sides parallel, and we show that with like little arrows. Double arrow, like that. And if you've got your height, which is there, height, and your base, which is there, and your area here is just going to be just like a rectangle, it's going to be base times height. Nice easy one, that was terribly drawn. Base times height. And so that's the area of your parallelogram. I'm just going to run through these and then do some examples. Okay. Fantastic, you've got those, you've got trapezium. So we've got trapezium, which is just sort of like your trapezium has these sides parallel, and that's all you sort of know about it. So if this is distance A up here, this is distance B. I'll give you arrows so I know what distance I'm talking about. That's A, and that's B there. And if it's got some height H, then the area of this particular shape is going to be half A plus B times H. In other words, it's the average of A and B, A plus B divided by 2, times by the height. That's how I think of that one. Fantastic. Any sort of rhombusy kite type shape, so anything that looks like this, where you've got similar length there and there. It could also be the perfect rhombus sort of shape, sort of just not very well drawn sort of thing. But if you've got a rhombus which has all the sides the same, it looks like 90 degrees, but don't think of that as 90 degrees. It could be, but not necessarily. So what you've got, if you've got this sort of distance that goes across the kite, and this distance that goes across the kite like this, if that's length y and that's length x, and the same goes for a rhombus, length x and length y, then your area for these shapes is equal to half x times y. Okay, so that's a easy one to remember too, because it's very similar to triangles. And last one, I think the only other one we have to do is circles, which is probably one you've all been waiting for. So if you've got radius r there, then the area of your circle is equal to pi r squared. Just in case you've forgotten, that's equal to pi times r times r. Some people prefer to think of it like that because they know how to enter it in the calculator, or that helps, but there you go. So there's all our formulas. Let's just go and do a couple of examples. I'm not going to do triangle. Oh, I'll just do one triangle. Okay, I'll do the one that confuses everyone. In fact, I'll just do it even more confusing, make it a bit more interesting. Okay, do that one. And let's say that this here is 11.1. I'll just leave that as 11.1, and I'll say that this distance here is 6.2. Okay, so there we go. We've got some sort of triangle, and now you need to look for a base and a height. So that, just so to clarify, is that distance there. Okay, so a base and a height. If you can picture this as being spun around, so I'm just going to sort of, to help think about this. So if you spin that around sort of that way, then you'll get that this 11.1 is the base. So let's write that down. The base is 11.1, and then your height will be 6.2 if you spin that around 90 degrees, standing like that. So therefore, your area will be half times base times height. Always write down the formula. Really good habit. Half times 11.1 times 6.2. Go to your calculator. 11.1 6.2. So 0.5 times 11.1. What was it again? Times 6.2. Is that right? 11.1 6.2. 34.41. 34.41. So that's my area. Too easy. We haven't been told what the units are, but you must write a unit in every answer. So we just say it's units squared. Okay, it's area, so it's squared. It's 2 dimensions we're talking about. We're talking about 2-dimensional area in here, and so that's 2-dimensional. It must be units squared. Okay, make sure of that. Fantastic. I might do a trapezium. No, I'll do a circle. I might just do an interesting trapezium. Okay, so let's do this one. Let's say that it has a circle with diameter of 16.3. It's got a diameter of 16.3. Find the area of that guy. Okay. Firstly, the formula for area of a circle is pi r squared. Now, what is r? Okay. In this case, r is equal to half of 16.3. Okay, so 16.3 divided by 2, because the radius is half of the diameter. So 16.3 divided by 2. Should I do it on my calculator? It would be 8.15. Okay, you can do that in the calculator. There we go. Good. So let's plug that straight into the formula. Pi times 8.15 squared. So let's do this. Put it into your calculator. Pi times 8.15 squared. Pi times, I'll put it in brackets just in case. You never know if it, the calculator might try to muck it up. 1, 5, and we want to square that. Squared. Close the brackets. I don't think you need the brackets, but anyway, is 208.67. 208.67. What are my units? Again, there's no units included, so I'll just write units squared, and that's my answer. Okay, I might just do one sort of more tricky one. Just remember, when you've got sort of what they call composite shapes, you just need to add all the areas up together. I'll show you what I sort of mean by this. So if you say had a shape like this, right. Should I make it a little bit more interesting? Alright, I'll just make it a little bit. Is that okay? I don't want to annoy everyone. I'll just make it like this, and this, and this. Oh yeah, that's good. Okay, right, yeah. So that's the center of that sort of circly bit. Okay, so let me just put put things on here. Let's say, I'll keep it simple for today, so that's 12 meters. Let's say this distance here is, I don't know, is it a bit more than 12? Let's say 17 meters. And let's say this straight, that is a straight bit there. Let's say that's 2 meters there, and let's just say that this distance here is 3 meters. Okay. So you're asked to find the area of this. Now, when you've got an area of a composite shape, what we mean by a composite shape is a shape that's got different things added together. So if we want to find all this area inside here, can you divide it up into sections that you know the area of? What we mean is, well, obviously here you've got a curvy part, and so I'm about to die with power. See if I can finish this video on time. We've got half a circle there, so that's half a circle in there. So we've got to find that. Also, if we put this partition across here, we've got a rectangle, so we can find that area too, no problems. And also up here we have a trapezium, and we can find that area there as well. So really our area is going to be just all these three added up. It's going to be a rectangle plus half a circle plus a trapezium. So let's do this. Firstly I'll find the area of our rectangle. Rectangle is equal to, simple, it's just 12 times 17. 12 times 17 is, I'm just going to get the calculator out. 12, should do that in my head, shouldn't I? You'll forgive me. 12 times 17, 204. So that's equal to 204, that's easy, that's that first bit. Half the circle is equal to half times half of pi r squared, which is half times pi times. Now what's the radius of this circle here? Well, that is 12, so the radius will be half of 12, so that will be 6 squared, half of pi r squared. Okay, and that's equal to half times pi times 6 squared. What am I looking for? Half, so half 0.5 half times pi times 6 squared equals, we get 56.55. 56.55. Good, so that's that one. And lastly, our trapezium. What is that? That's equal to, the formula is basically the average of the top and bottom. So I'll just write this as a plus b over 2 times by the height. Okay, so the average of the top, which is 2, so 2 plus, what's the length of the bottom of the trapezium, is 17. Divide that by 2 and times it by the height of the trapezium, which is 3. So what do we got here? We've got 2 plus 19 over 2. It's not going to be nice. 19 times 3, it's not going to be nice, I'll just do it on the calculator. So 19 divided by 2, 19 divided by 2 equals, and then times it by the height, times by 3 equals 28.5. So it's equal to 28.5. Therefore, our total area is equal to, add them all up together now, we've got 204 plus 56.55 plus 28.5. Add them all up together, your grand total is 28.5, will already be in the calculator, just need to add 56.55. So add 56.55 plus 204, I think it was, I hope, 204, into 289.05. 289.05, and we're in meters. It's in area, which is 2-dimensional, so it must be 289 meters squared. There's your answer. Have fun.